Without any waste of time, it's my pleasure tonight to introduce to you Mr. Bill Hoesh of the Institute for Creation Research.
Hello, can you hear me okay? Well, good evening, everybody. It's a privilege to see you out on a Wednesday night. This is pretty neat. My wife and I'd like to thank the leaders of the church, including John Brown, including and our friends Jerry and Linda Hensler, who helped organize this event. They have a nice table outside. I hope you take your time to look over some of the things there. They got some good stuff. My name is Bill Hoesh, as I said, and my wife Alicia is with me. She's sitting in the back, and you can stand up, sweetie, if you like. Yeah, and we've traveled from a different land. We're from Southern California. And even though it's not exactly coconut palm trees swaying in the breeze, it's a little different from that. It's a lot different than it is here. We're visiting with Alicia's family in Schoharie County. So we're there for a holiday vacation. And glad to come out and share with you guys just a little bit on evidence for creation. All right, let's see if we can. I'd like to share with you, and by the way, I'm from the Institute for Creation Research, and in Southern California, that's the institute where we believe that you can take God seriously at His Word, including details like a 6-day creation, including details like a worldwide flood, including details like a dispersion from a Tower of Babel kind of an event, and that these events are historically reliable, and we don't need to alter them or modify them according to what we think the whim of the day might be. And so we think that these things are binding and that they're true. And truth is an important word for me. I was raised in a home that was a nominally religious home, and I can distinctly remember when my oldest brother came home from school and told my mom, said, "Mom, you know, if I have to choose between religion and truth, I've got to go with truth." And what he meant by that was he's a biologist today, and he was studying Darwinism at the time, and it was his bailing out point. It was the point at which he departed from any kind of religious or any kind of a faith-based system in God. And it was my bailing out point too. It was many years later that I heard in Scripture that says, those who love truth must worship in spirit and truth, right? And so that's in that spirit that I come to you tonight. And so I'd like to share with you evidence from a volcano, Mt Saint Helens, and I'd like to take you through the eruption, the events leading up to the eruption in May of 1980. I'd like to look at the little bit of the aftermath and what kind of lessons can we learn from this eruption. And then in the second, we'll have a little intermission, and the second talk will be a little more brief. I want to give you just a few tidbits of some of the research that we've been involved in the last 8 years on radioisotope dating, which is the only method that geologists use to assure us that the Earth must be 4.5 billion years old. And we tend to think that there's evidence there that indicates the Earth might be much, much younger, and I'd like to share some of that evidence with you tonight, Lord willing. Okay, so how's that sound? So let's see if we can get underway. And I'd like to begin with a scripture, if we could. I'd like to begin with 2 Peter chapter 3, and just a brief passage, and then it'll be mostly a slideshow after that. 2 Peter chapter 3, and this is Peter's last words to the church. And it says this, "Beloved, I now write to you this second epistle in which I stir up your pure minds by way of reminder, that you may be mindful of the words which were spoken before by the holy prophets and by the commandment of us, the apostles of the Lord and Savior." So he's saying, hey, I want you guys to pay attention to what was written in the Old Testament and the New Testament. Knowing this first, and he gives a warning here, verse 3, knowing this first, that scoffers will come in the last days, walking according to their own lusts, and saying, where is the promise of his coming? That is the coming of Christ. For since the fathers fell asleep, all continue as they were from the beginning of creation. For this they willfully forget that by the word of God the heavens were of old, and the earth standing out of water and in the water, by which the world at that time perished, being flooded with water, right? So Peter warns about these scoffers in the last days who are going to come along and they're going to say, they're going to deny Christ's second coming. They're going to say, where's the promise of his coming? For ever since the fathers fell asleep, everything continues as was in the beginning. I say to myself, where have I heard that phrase before? I know where I've heard that before. On page 1 of almost any geology textbook you want to pick up, there's this philosophy called uniformitarianism. Anybody ever hear that? That's a big nickel word. Yeah. And it's this idea that, hey, if you want to explain large-scale features in the Earth's crust, things like giant canyons, things like sedimentary rock layers that extend over vast areas, you appeal to present-day processes. And when you do that, you automatically wind up with a time scale that's billions of years old. There's no alternative. And out the window goes the flood, out the window goes creation, and Peter says, look out for these scoffers because they're going to come. Well, they came, all right, in the 1700s and 1800s. They came in force. A philosophy called uniformitarianism that basically overturned the science of geology, turned it from a God-honoring science into what we have today, which I think is, the facts are good, but the interpretation is not so good sometimes. Well, that particular philosophy takes some hits at Mt Saint Helens. I'd like to share with you some of those hits tonight. So if we could dim the lights a little bit, I'd like to go ahead and proceed into the talk. Maybe close the lights. And you guys who want to appreciate, we're going to be looking at pictures. You might want to come a little bit more forward. There's seats right up in the front here if you want. I'm not offended if you want to get out and walk out in the middle of it. That doesn't bother me a bit. So yeah, I know what it's like when you go to a meeting and you don't know who's speaking, but it doesn't bother me a bit. Mt Saint Helens, explosive evidence for catastrophe. Mt Saint Helens was a beautiful cone-shaped volcano before the eruption of Mt Saint Helens. I'd like to look at tonight, I'd like to give you a little outline. I want to look at, number one, the events prior to the May 18th eruption. Number two, the eruption of this volcano. Number three, the aftermath. And number four, lessons we can learn from it. And some of the lessons include rapid formation of strata, rapid erosion, rapid burial of upright logs, rapid formation of coal, and rapid biological recovery. These are just some of the things we can learn from a volcano like this. I notice in New York State, you don't have a lot of active volcanoes, right? So I hope we can benefit from this here. All right, Mt. Saint Helens, prior to the eruption, it was a very scenic mountain. A very peaceful lake called Spirit Lake lied at the foot of this mountain, and backpackers and fishermen and campers would travel all around. This is called the Mount Fujiyama of the Pacific Northwest. This is kind of what it looked like. You can see sailboats out on Spirit Lake. That's the lake that lied immediately to the north of the volcano. And beautiful cone-shaped volcano. And it's the same kind of volcano that you do see in Mount Fujiyama, same kind of volcano that you see in Kilimanjaro in Africa, the Aleutian Island chain. All around the Pacific Rim, you see volcanoes of this sort. It's what's called a composite cone volcano. It's made up of alternating layers of volcanic ash and lava that have built up over the course of probably only a few thousand years in the case of Mt. Saint Helens. Nobody says this volcano is millions of years old. And this volcano, this particular type of volcano, has the habit of sometimes exploding violently. And that was the case in May of 1980. And in this picture, you can see some of the, this is the pre-1980 profile of the mountain. And you can see, I hope you can make out, kind of lava flows that have oozed down off the side of it, giving you this impression that this is indeed a cone-shaped volcano, like I mentioned. Little orientation for you, just to show you where we're at here in the Pacific Northwest. Mt. Saint Helens is one of several isolated mountain peaks in the Pacific Northwest, Mount Rainier, Mount Hood, and several other mountains in the Pacific Northwest that are potentially active volcanoes. And this is a map that might help you to get oriented a little bit. On the bottom of this map, you can see the summit of Mt. Saint Helens, 9,700 feet tall, Spirit Lake about 6 miles to the north, a place called Bear Meadow, 11 miles to the northeast. I want you to understand the geography a little bit because we're going to be referring to these. And the North Fork of the Toutle River drains to the west and it ultimately drains into the Columbia, into the Pacific Ocean there. And this slide is colored sort of a color green to indicate this is a richly forested area. This is timber country in the Pacific Northwest. After the eruption, what did this map look like? "150 square miles of forest was toppled in 6 minutes, leaving about 1,300 feet of the summit was removed from Mt Saint Helens, leaving this horseshoe-shaped crater. North Fork of the Toutle River is actually downcut into its own material that was eruptive material that came to rest there, forming a canyon there we're going to talk about. And Spirit Lake occupies a new area in space, and they had to re-engineer drainage, new drainage for it to keep it from further catastrophes from happening there. So this is a scene of a lot of devastation. I was there in 1984, 4 years after the eruption, and let me tell you, it was a scene that would take your breath away to see a desert-like landscape in the Pacific Northwest where you don't see it, where everything's green. You see that, it's amazing. Well, let's go through the events leading up to the eruption if we could. March 20th of 1980, there was a 4.2 magnitude earthquake underneath the summit. The volcano was awakening. After 123 years of dormancy, Mt. Saint Helens was waking up. Steam was seen issuing from the summit, and eventually a crater opened on the top of Mt. Saint Helens. The volcano was clearly awakening, and then it had some early, this is a view to the north, you're looking at Spirit Lake in the background, early steam eruptions there, and on about a week later, there was the first eruptive products from Mt. Saint Helens in 123 years. And the people in the area, they thought this is jolly and fun, the volcano's waking up. Let's collect some volcanic ash and we'll sell it to people on the roadside. And the people thought this was a lot of fun. Little did they know the volcano was about to go into full-scale eruption. This is a view looking on top of Mt. Saint Helens. This is the crater opening up on the top of the mountain. You can see a small airplane for scale. I hope you can make that out from there. And it was around this time that scientists made a startling discovery. The north flank of the volcano had been swelling about 5 feet a day for the last couple of months, and there was a bulge off the north flank of the volcano, 450 feet out of its normal profile. It was like an oversteepened bulge of material that any kind of a slight earthquake could dislodge into a large landslide. And people were warned at this time to get out of the area. Only scientists and other people were allowed to stay in the area, but not everybody heeded the warning. Nevertheless, people were warned on May 17th. This is a picture taken on May 17th, one day before the eruption. Morning of May 18th rolls around. Beautiful Sunday morning, clear skies. 2 geologists were flying overhead in a small airplane, and they took this last image of the volcano profile before the big eruption took place. They're flying overhead, and by the way, the Pacific Northwest, it's really unusual to see a sunny day, much less a Sunday when you have you can enjoy your day off or something. And these 2 geologists are flying overhead, and they notice some peculiar things happening. They're flying right over the top of the volcano, and they notice rocks tumbling off of the crater lip into the volcano. Only a few moments after that, they noticed the whole north flank, that oversteepened bulge. In their words, these are geologists, they said the whole north flank of the mountain was rippling and quaking, right? Like a bowl of jello, right? Only moments after that, the whole big landslide slipped loose. This view here is an amazing photograph. This is the largest landslide ever captured on film. You can see a little bit of steam and ash issuing from the head of this slide, steam and ash issuing from the toe of it. There's a deep-seated fault plane right on this side of the mountain. That's about a half of a cubic mile of material that's sliding out, rock and ice moving out at high velocity here at the largest landslide ever captured on film. This had the effect when that landslide slid out, all the superheated water and other volatile gases that were mixed in the magma chamber, they flashed to steam. And when that happened, that was the shock blast of the northward directed surge blast that came out of the volcano at tremendous velocity. You can see the tail wing of the airplane in the upper right. The thing is banking he went into a steep dive and banked around the backside of the volcano. I'm sure he was thankful that the volcano erupted just when it did, instead of a few moments later. This is a view taken from about 11 miles to the northeast, a place called Bear Meadow. A man named Keith Ronholm and another man named Rosenquist were camping, and no doubt they felt that big earthquake shaking the ground. They had their cameras set up. One of them started snapping pictures of the volcano. They didn't get the landslide, but they captured events shortly after it when this northward directed steam blast, steam and ash are coming out here well over 300 degrees centigrade, and it's a ground-hugging slurry of hot ash and steam that's proceeding northward at about 200 miles an hour. Large pieces of ice and rock are being hurled outward at tremendous speed here. This thing is traveling 200, maybe several hundred miles an hour. They take another picture, and the steam and ash cloud is advancing on their position. Keith and his friend make a very wise decision at this point. They get out of there as fast as they could, all right? They take off down that old logging road, but one of them took one shot over his shoulder as they were fleeing, and this is what he saw over his shoulder. That's a superheated, that's not soap suds you're looking at. You're looking at superheated ash and steam that's literally toasting everything in its path, right? I'm sure these guys thought they were dead. Little did they know, the ridge that they were standing on was just sufficient to deflect the waning energy of this steam and ash cloud up over their heads, and they fled northward underneath it. Their car was pelted with golf ball-sized pieces of volcanic ash and pumice, and it was pitch black, but they made it out of there with their lives, and they made it out with some amazing photographs and no doubt some great stories to share with their grandkids, right? And if they would have stayed where they were on the lower right there, they'd have been toast for sure, right? So it's quite a harrowing story of escape here. After this northward directed blast, then the volcano went into full-scale vertical eruption, right? There's a column of material going up about 15 miles into the atmosphere, well into the jet stream, well above the level that jetliners fly at 40,000 feet. This is probably more like 70,000 feet into the upper atmosphere. Now, volcanic ash, I don't want you to be mystified by these words. Volcanic ash is simply when that magma is shooting up through the neck of the volcano, that liquid rock, it solidifies in midair into tiny little particles, very abrasive little particles called ash, silt-sized particles. And so that's what ash is, nothing mysterious about it. This is just a more close-up view, and then we have another closer view yet of this plume of material that's lifting right up into the atmosphere. It was in this what's called Plinian stage of eruption for about 9 hours that day. The energy output at any given moment is about 1 atomic bomb per second, sustained over a 9-hour period, right? 1 Hiroshima-sized atomic bomb every second going off over a 9-hour period. The people who lived in that area who witnessed this, they all said the same thing. They thought the world was coming to an end. The blast, by the way, the blast from that initial northward direct steam blast was heard hundreds of miles away up in British Columbia, out in Montana, and in Southern California, or Central California, I understand. All right. This is another view of the volcano erupting. In the lower, on the left side, you can see another cloud that's sort of streaming off the left side of the volcano. That's what's called a pyroclastic flow. That's like a flaming, hot, ground-hugging slurry of hot material that just goes out at hundreds of miles an hour, and those things are particularly devastating, right? Pyroclastic flows, and then the Plinian plume, the vertical material. This shot was taken, this is a satellite image. You can see the Pacific Northwest here, and you notice the donut-shaped cloud defining where the eruption is at. This was taken about 43 minutes after the initial eruption. Later on that same day, volcanic ash was being spread over a 6-state area. Within 2 weeks of the eruption, volcanic ash was in measurable amounts in the atmosphere around the world. So that's what happens when these big volcanoes jet material in the upper atmosphere. It can actually alter the global climate. We know that can happen, right? And I happened to be working in western Wyoming at the time, and we had some beautiful red sunsets and a little dusting of volcanic ash. I didn't think too much of it. I had no idea of the magnitude of this thing when it was going off. This is a view in Yakima, Washington. The streetlights turned on around 12 noon that day. It was pitch black. The streetlights turned on automatically, and people were warned to stay in your homes. Don't venture out into this abrasive material. We don't know what it'll do to your car engine. Nobody knew anything about how to respond in an emergency like this. Eastern Washington looked like a fresh snowfall happened. This is way out in eastern Washington. It's not snow, that's volcanic ash resting on the ground out there. Again, later on the same day of May 18th. Well, we can now begin to evaluate the aftermath of an eruption like this. About 1,300 feet of the summit was removed, and you can see the original profile of the mountain there, leaving a horseshoe-shaped crater with a smoking in the center of it is what's called the lava dome in the middle of it. And this is another view to help you appreciate the damage. I don't know if you remember the beautiful pristine green forest and the beautiful idyllic lake scene in front of it. This is what happened afterwards, right? We can review the events once again, just for refreshment. The landslide slid northward, that is toward you in this photograph. Much of the landslide slid into Spirit Lake, but the larger portion of it kind of caromed to the right side down the North Fork of the Toutle River drainage there. And Spirit Lake is kind of in the shadows to the left. Now, you know what happens, don't you, when a large landslide enters a body of water? It gives that water a good shove, doesn't it? Try it in your bathtub sometime, right? It gives that water a good shove, and it produces, at the far end of the lake, it produces what? It's a household word now, right? Tsunami. Yeah, it was right around this time of year when the big tsunami hit, wasn't it? And the tsunami in this case was a big one. Nobody captured it on film, but the scour marks were evident on the flanks of the mountain. 860 feet, that wave washed up the far side of the lake. It's perfectly obvious from the scour marks on the side, and also from about 1 million logs that covered the surface of Mt Saint Helens after this eruption. Landslide debris like this moved down the valley, the North Fork of the Toutle River Valley, leaving deposits, these kind of hummocky kind of deposits of landslide debris 13 miles down that valley. The valley does not have a steep gradient. Scientists to this day are not sure how these long run-out landslides can be sustained over 13 miles at a very low gradient. Nobody understands how these processes work. It serves to underline one important thing, that catastrophist geology is a young science. Scientists are just beginning to understand what happens in large-scale catastrophes. It's an exciting thing to think about. This is a picture of Spirit Lake from near where the crater is. You're looking to the north. This is from the throat of the volcano here, and Spirit Lake this is the day after the eruption, I believe, about 100% covered with logs. This is a richly forested area. Those are great big Douglas fir and several other species of pine and so on, and fir that are covering that lake. The ground surface around the volcano, well, it was hundreds of degrees centigrade for weeks after the eruption, hampering efforts to evaluate damage, evaluate loss of life, and so on. There were 57 people who lost their lives in the eruption. Every one of them had a warning to get out and flee from the danger, because everybody knew it was a dangerous place to be. Only some of them were official people, including at least one scientist. This is David Johnston, who was a geologist. This picture was taken on May 17th, and he was on a ridge directly across from the volcano on the north side. One of the worst places to be. And he radioed in his laser results, had laser setups on the flank of the mountain because they were monitoring that big bulge, you know. And he had radioed in his readings, and the volcano gave nothing in the indication of anything out of the ordinary at that time. So he camped there that night, and the morning of May 18th, he got buried. And today it's called, if you go to that visitor center, it's called the Johnston Ridge Visitor Center, I think. Whoops, keeps jumping forward on me. Okay, sorry. Logging trucks hurled like toys, tens of meters in distance. No logging people were, they had all evacuated. This is a piece of equipment here that was blasted with, in the initial surge of the volcano. And we'll do a close-up on the grill. There's a grill on the side of that thing in which there's rocks, there's trees that were just blasted into the grill work on the side of this equipment here. And there's even a big log wedged in there. It was definitely a hostile environment, all right, when that thing was happening. That great big forest of these big Douglas fir laying about like so much straw, all of it blasted down. 150 square miles toasted in 6 minutes. Enough lumber, they estimate, to build 640,000 three-bedroom homes. That's how much timber was blasted in one 6-minute period. You know, now the timber companies who own this property, what do you think they thought? We got to harvest, boys, right? And they began firing up their chainsaws to cut up this wood, and they noticed their saws got dull quickly because of the abrasive nature of that volcanic ash. That's, and so they wound up donating this land to the federal government. Today it's a national monument, right? It sounds like they're being very generous, but they couldn't really use that lumber anyway, all right? Or it couldn't have been very effective. There's another idea that I've thought of. It's conceivable that some of those logs, I happen to know that wood in the presence of volcanic ash is susceptible to petrifying, and it can happen very quickly because volcanic ash is very unstable material in the presence of moisture. It wants to give up its silica. Silica is the stuff that can petrify wood. It's conceivable that there's petrified wood up there today, because I'll tell you something, petrified wood is not a process that takes long ages to form. You let me borrow your bathtub and I can stir in it the wood and the right naturally occurring chemicals, and I can form fossilized wood, silicified wood, in a matter of days. There's no reason to believe it takes long ages to form at all, right? Okay, that's a little bit of an aside. This is another view of some of the blowdown zone of the forest. You're out on the fringes of the blast zone where the forest was just knocked down here, and in some cases, this is a close-up here, and if you look closely, I hope you can see there's people for scale in the lower right there, little tiny guys, you know, really small. And so this was an area where the trees were knocked down and transported. Everything was instantly just oxidized off the branches. The greatest financial loss came in the form of mud flows. When you have a hot volcanic eruption producing volcanic ash, and that ash will mix with melt water from all the snow and ice, it produces a slurry, doesn't it? Geologists give that a technical word. We call that mud. Yeah, there were mud flows that came down off the volcano, like cement, like slurries of material, very dense, much denser than water. The properties, when they get moving at high velocity, that scientists are just beginning to wrestle with. They don't really understand how sediment moves in this kind of setting, but it is very powerful. They know that because it just wiped out logging camps, took trees, equipment, houses. No people were killed in any of these mud flows, but they're very, very dangerous kind of things. This is the remains of a logging camp here, and after some of the logs and mud just swept through it. You can see the mud line here on some of these trees that remain standing further downstream. And you're looking now at the lava dome in the throat of the volcano. This is kind of like the congealed, hardened rock that is solidified since the eruption. Now, there were several subsequent eruptions, the May 18th one. Over the course of the next several years, there were several eruptions. Each one began by jettisoning that lava dome out, and the eruption would proceed, and then it would begin to congeal, form a new lava dome, then another eruption would come, and so on. There were, I think, 6 or so of these kind of eruptions before it finally stabilized, and it's only semi-stable today. But it was in 1990 that a scientist with our institute got permission to go in there and collect some samples for the purpose of what? For the purpose of radiometric dating. Here is a rock that you know is solidified less than 10 years ago, right? Wanted to see, use the standard techniques of radiometric dating, potassium-argon age dating in this case, and it's theoretically a very elegant method. We're going to talk about that a little bit more in the next session. But he sent it out to the lab, again, with careful preparation and so on. He got dates ranging upwards of 2.7 million years for rock that we know is no older than 10 years old, because you're dating the age at which it crystallizes, when it solidifies, right? And this helps to underline something, doesn't it, right? Now, the scientists, they had a ready explanation for this. Well, they said, obviously, this is an eruption that had excess argon associated with it, and that's why I gave you the erroneous age date. But that just raises the question, doesn't it? How do you know all of your ancient unknown rocks, these rocks that you age date to be millions and millions of years old, how do you know they also didn't have excess argon with them, right? Because you don't have a cross-check with them. You don't know the real date. You're using the potassium-argon method to try to get the date, right? It underlines an important thing, folks. These dating methods are highly interpretive. And so when your theologians and your pastors begin to explain away, they say, well, maybe the earth is billions of years old, and really there was a big gap, or maybe their days were long ages of the creation week, or maybe this or maybe that, right? They're doing it on the basis of a highly questionable dating method, which yields numbers of millions of years old. And Mt. Saint Helens helps us to illustrate that. So I tell people, scientists are not able to measure the age of any rock. They can only interpret an age of a rock, and your interpretation is only as good as the assumptions that go into that method. And there's very good reasons to question those assumptions. We'll talk more about that in the next session. All right? You're looking now, okay, now we can start to learn some lessons. What kind of things can we learn from an eruption like this? Well, there's a lot of cool things for me as a geologist that get my attention. You're looking here, you're looking to the west. The volcano is off to the left side of this field of view, and you're looking at an area called the pumice plain. That hummocky kind of terrain out there is the landslide debris. And it was mud flows that came down off the volcano and actually carved canyons right through that debris and reveal some interesting things. This is one of these canyons. It's a canyon cut in one day by a mud flow, right? It's about 100 feet deep. And if you notice carefully, there's a layer of material that's very well bedded in the middle portion of that view. It's about 25 feet thick, and it's layered, right? And I always thought as a geologist that layered rock took long ages to form. That's what I always learned in geology. Yet that 25-foot thick layer formed probably in a matter of minutes. That did not happen over long ages at all. And you can see the layering up close, and you can see it even at a finer scale, even at a finer scale yet. Whoops. I'm having trouble with this. There we go. At a finer scale, even at millimeter scale laminae, wow, what was going on? This was like a hurricane velocity pyroclastic flow that deposited this layer of material in a matter of minutes. Wow, how can it get such a layered look like this? Is there something that goes on in these, oops, is there something that goes on in these pyroclastic flows? That's a picture of a pyroclastic flow streaming off the mountain there in one of the subsequent eruptions, all right? What's going on inside of that thing, all right, to form the layering? Well, geologists, again, they're beginning to wrestle with these things, and you'd be amazed to know that geologists are beginning to wonder how layered rock forms in places like Grand Canyon. Now, this is sedimentary rock. This is a sandstone called the Pete sandstone at the bottom of Grand Canyon. And it's a sandstone layer that extends across most of North America, even up here in this region. There's a layer of sandstone called the Potsdam sandstone. Anybody ever hear that? I think it's used for building facings sometimes. Same layer is exposed here in this picture in the bottom of Grand Canyon. It's part of a continent-wide blanket of sand. Scientists are beginning to realize now that the sediment dynamics involved in depositing this kind of thing may have been very, very similar to the kind of thing that went on in a pyroclastic flow in a volcano, if you can believe it, right? It really is true that people are beginning to wrestle with these kind of things in ways that were unthinkable only 10 or 20 or 30 years ago, that scientists are beginning to rethink these kind of ideas. Is this the kind of thing when you see a continent-wide blanket of sand like this that could have been deposited in a catastrophic fashion similar to a pyroclastic flow, is that the kind of thing you'd expect would have been going on during Noah's flood? As a geologist, I'd say, yes, it would. If the Bible speaks truth, that seems to be consistent with it, right? Other things we can learn. How about some examples of rapid erosion, right? You know, when that hot blanket of volcanic ash came to rest around the foot of the volcano, there was lots of snow and ice on the ground around there, and some of that snow and ice, it flashed to steam, and that steam would blow holes up. These are kind of secondary explosions, or kind of, they call them rootless explosions, and there were dozens of them that happened, and they left behind these things called steam explosion pits. Now that thing's about 200 feet deep, and it's got edges around it. It's kind of a big feature, but there were dozens of these things that formed as a result of steam blasting through the ash blanket. And around the edges, I've seen that landform before, that kind of look. That's kind of like a Badlands look. We call it rill and gully erosion. I always thought as a geologist that's a sign of a mature landscape, something that maybe developed over hundreds of thousands of years. But I'd be wrong in this case because that landform formed instantly. That did not form over long ages, right? So you see how you can be misled by the way things look. Sometimes this earth looks to be very ancient, but you have to wonder how much that is philosophy and how much is that is reality, right? Canyons to the tune of 200 feet deep, carved by mud in a single day. That's a lot of geologic work. Here's a steep-walled canyon here. It actually carved down through the pre-existing hard rock of the volcanic edifice. The whole, this is andesite, hard rock that you can hit with a hammer and it rings, carved 200 feet deep in a single day by a mud flow. This is what one of those mud flows looked like. This is a 1982 eruption with a mud flow that came down off it. That's a cement-like slurry that does tremendous erosive work, and carved a whole series of canyons there in that 1982 one, including this. This is a helicopter shot of a network of canyons in the North Fork of the Toutle River area. In fact, these canyons, they tend to have flat tops and steep walls, and sometimes a little stream running down the middle of them, right? That canyon was carved in a single day by a mud flow. But you might come along and you might look at that little stream and you might think, boy, it must have taken that little stream a long time to carve that big canyon. But you'd be wrong there, wouldn't you? You'd be what's called a uniformitarianist if you said something like that. You'd be believing that the present is the key to the past, that everything continues as it was in the beginning of creation, like the scoffers of Peter mentioned, right? But you'd be wrong here because I happen to know that that canyon formed rapidly in a single day. Makes me wonder, as a geologist, how large canyons formed like Grand Canyon. Grand Canyon, one of the great wonders of the world, isn't it? All right? This is a satellite image of northern Arizona, and you can see the Colorado River begins in the upper right, cuts across this big upwarped area. In the false color imagery, it looks brown, right? And then it cuts westward and eventually dumps into the Gulf of California, all right? How did the Grand Canyon form anyway? You know, there's three theories for the formation of Grand Canyon. One, a lot of water and a little bit of time. That's one theory. And you know, the Havasu Indians believe that. The Havasu Indians are people who live in this region here, in this kind of yellowed area that's called Havasu Canyon there. And they believe that the gods got angry one time and they sent a big flood on the earth. And when the flood waters receded from off the earth, it carved Grand Canyon. So they believe a lot of water and a little bit of time. Now, there's other ideas. The second theory for the formation of Grand Canyon is that it was a little bit of water and a lot of time. In other words, that little Colorado River over millions of years carved the Grand Canyon, just slowly plucking one sand grain at a time over long ages. all right? And that's been modified considerably now. It used to be 65 million years, then it was 10, and now they say it happened in under 1 billion years, they say the river did it, all right? So there's changing going on there. And then the third theory is that the Grand Canyon got started when a Scotchman lost a nickel down a gopher hole. Scotchmen are known to be thrifty people and so on. Okay, never mind. Yeah. All right, so I kind of like that first theory myself. A lot of water and a little bit of time. You know, you'd be amazed that geologists today have recognized in that upper right portion there of this image, lake bed deposits up there. It looks like there was a huge lake occupying that area, which is relatively low-lying compared to the brownish uplifted terrain called the North Kaibab upwarp. Now, if there was a large lake or series of lakes like the Great Lakes occupying northern Arizona up into Utah, and if those lakes failed, you could have a breach dam model for the formation of Grand Canyon. In other words, a catastrophic formation of the canyon, down-cutting through this uplifted area, which would have been like a big dam, and you could have had like a dam failure, right? And there are secular scientists at University of Arizona and elsewhere who are championing that theory today, and they're not creationists who are doing it, all right? In other words, they're being compelled by the evidence for catastrophic work in a short period of time, which is very exciting to me, all right? Well, another little piece of evidence we can look at, this is kind of fun. My colleague, Dr. Steve Austin, was eating his lunch at the shores of Spirit Lake, 1984, and he noticed some sticks floating in the lake. Most people wouldn't pay much attention to this, but he started drawing cartoons in his notebook like this. And because he knew there was about 1 million floating logs in that lake, and he was thinking, what happens when those logs get waterlogged? Do they settle to the bottom? And what happens to them, you know? Well, he started thinking about this. There's a picture of Spirit Lake covered with big logs, 6-foot, 8-foot diameter trees floating in a big lake. They're eventually going to get waterlogged. How are they going to sink to the bottom? Are they going to sink in a prone position? Are they going to sink vertically? What's going to happen, right? This is a satellite image flying over the surface of this floating log mat. You can see a few logs beginning to go upright in 1984. Some logs were beginning to was like a small school of upright floaters here, right? All right, and he wanted further confirmation of this, and so here he is. This is two scientists, Dr. John Morris and another scientist, decided to go out in this research vessel with what's called a side scan sonar in the back, that yellow fin cigar-shaped towfish they pulled behind the boat to get an image of the bottom of the lake to see what it looked like down there. And they got an image, all right, indicating about 20,000 of the portion of the lake they were able to cover, which is only a small portion of it. They determined about 20,000 upright logs were standing vertically in the bottom of that lake. In other words, if you drained Spirit Lake, it would look like a forest, right? But those trees didn't grow there. They got replanted there, didn't they? Very interesting. Right? And further confirmation of this was wanted. So this is Dr. Steve Austin, my colleague, and the scientist who did most of these slides you're looking at tonight, and his diving buddy. He's a certified diver. They went down underneath the log mat here, and they posed for effect, of course, with the volcano in the backdrop, upright floater in between them. Down they go underneath the log mat, and they're able to determine upright floaters. And they went down into the murky depths, cold water depths, about 60 feet down, and they're able to determine, indeed, logs vertically. They could just get pictures. It's kind of a crude picture, but they're able to confirm that there are logs standing vertically. And they notice that these logs, they tend to have their roots terminate very abruptly, right? And why do their roots terminate very abruptly? Because these trees were swept into the lake by that giant water wave, right? That's what water does at high velocity. It can cut those trees like soft butter, sent them tumbling into the lake. It's unquestionably true that those things were transported catastrophically into Spirit Lake, and they got replanted there. Now, who cares about a bunch of logs standing vertically on the bottom of Spirit Lake? Well, there's a place in Yellowstone National Park. It's a different region now, in Yellowstone, there used to be an interpretive sign on the roadside. It's kind of fun. And the interpretive sign said, you're looking here at a place called Specimen Ridge. And at Specimen Ridge, this is what the mountain looks like here. They said there's 27 different layers in the rock where there's ancient forests that were buried, where one forest was buried, and then another forest grew on top of it. It got buried under volcanic material. Then another forest grew, and then it got buried 27 different times. And scientists used to use that to ridicule creationists. They'd say, how do you guys possibly get off on saying this earth is 6,000 to 10,000 years old? All I got to do is go to Specimen Ridge to disprove that, because there you got 27 different levels of trees that must have grown in sequence here. Well, they did some more looking at those trees at Specimen Ridge, right? And they noticed that this is a picture of some of these petrified trees at Specimen Ridge in Yellowstone National Park. They have no tree limbs on them. Their root ends terminate very abruptly, interesting, much like the logs on the bottom of Spirit Lake do. There's no real soil horizons that join these trees at root level. In fact, the levels kind of fall out at irregular levels. It's not a real soil zone. There's not a lot of organic material buried around them. It's a peculiar kind of deposit. The real clincher came when a PhD student, he took core samples. He drilled into these petrified logs and extracted cores and analyzed the tree rings. And the tree ring pattern of the trees, the fossil trees at layer number 1, matched those on layer 27. In other words, even though these trees were buried at different levels, they obviously were trees that once grew side by side, right? In other words, you're looking at something that was a catastrophic burial, except it's on something on a much larger scale than Mt Saint Helens here at Yellowstone National Park. Well, did you know they took the sign down from the roadside exhibit there at Yellowstone? And it happened shortly after a concerned citizen who happened to be a creationist wrote a polite and intelligent letter to the Park Service, said, you guys need to get a little up to date here on your research. Don't you think you need to do something about that sign? And you know, they took it down. They never sent him a letter, but they noticed the sign disappeared shortly after the letter was sent, right? So sometimes you have your impact, you see, and you don't get to see it, you know? Anyway, so this is interesting. Upright fossil trees, another lesson from Mt Saint Helens. And then one last geologic lesson has to do with the origin of coal. Now, coal is a very important economic resource, right? And coal, everywhere we see it in the Pacific, in the Midwest and regions like Pennsylvania and so on, tends to be a layered black organic material. And the organic stuff that makes up coal seems to be dominantly tree bark, interestingly enough. It's not dominated by other kinds of organics, but mostly tree bark. That's what it looks like. And models, if you ask geologists, how does coal form? Well, they usually wave pictures like this in front of you, right? Here's an ancient swamp millions of years ago, right? And when these trees, they would die, they'd fall over into the swamp, and they'd get pickled in the low oxygen, slightly acidic waters of the swamp, and there they'd get buried with pressure and temperature, get converted to coal. Makes a nice story, right? Well, they've looked at modern-day swamps. Modern-day swamps, guess what? They're not layered like your ancient coal beds are. Modern swamps are root penetrated. There's no great preponderance of tree bark in them either. It's a mixture of organic remains. It's not tree bark. So these modern day swamps form a poor analog for how the ancient coal beds form. So it's kind of a mystery how coal forms. Well, along came a student in 1979, a student at Penn State University, your leading coal university in the United States. He had a radical idea for the origin of coal. He said to his professors, he said, look, I've got a theory that says, you know, maybe North America went underwater with a big flood. And maybe there was a lot of floating trees around, and they kind of blew together and formed a big log mat. And when the log mat was being blown around, the tree bark rubbed off the trees and settled to the bottom, forming a layer of peat. That's a tree bark-rich layer of peat. And so you could deposit a vast layer across the surface of the continent by this kind of method. Well, what do you think his professors told him? By the way, the student was Dr. Steve Austin, the colleague that I work with today. All right, that was the student. All right, and what do you think he told him? They said, Steve, we think your ideas are preposterous, ridiculous, and absurd. But you know what? They explain the origin of coal better than our swamp model does. So thank you very much for your hard work, and you've defended yourself, even though it's ridiculous and absurd. Here's your PhD. Please be on your way. Right? And so he graduated from the leading coal university in the United States, probably in the world, with a radical flood model for the origin of coal. So sometimes it pays to stick to your convictions about what you really believe that God said in his word. All right? He believed there was a global flood. And he believed it enough to put a sharp pencil to it and do his homework, you see. And anyway, it's inspiring to me. It's a great story to me. I hope it inspires you as well. Well, what do you think he wanted to do? He got his PhD in 1979, and in 1980, there's Spirit Lake, 3/4 covered with logs. What do you think he wanted to do? You bet. Here he is with his diving buddy. They went down underneath that log mat. Now, this is actually several years later. This is a little bit out of sequence, but they went under that log mat and they found what? Sheets of tree bark on the bottom of Spirit Lake, a 3-foot thick layer across much of the lake, at least, of tree bark-rich peat. Right? The perfect scenario for the origin of coal. This doesn't prove this is the way your ancient coal beds formed, but it does vindicate one part of his model that tells you that, yes, you can imagine a scenario by which you could produce coal in this fashion. And he has since defended his coal ideas at professional coal societies in the United States and in Canada. And they tell him the same thing. They say, Steve, we think you're a little kooky and we think your ideas are a little religious and nutty, but you know what? It explains the origin of coal better than our swamp model does. Thank you for coming. Please be on your way, kind of thing. You know? So that's a little bit about the origin of coal. Some amazing things you can learn from a volcano like this. And then a little bit about the rapid regrowth and recovery that kind of boggled biologists a little bit. Everybody was placing their bets what the first plants would be to colonize this lunar landscape that was blasted out. And now this is more in the fringe of the blast zone here, where you can see some of the wood is laying around. By the way, in the inner ring of the blast zone, for about an 8-mile radius, all the trees were not only blasted, they were blown out. They were just transported outward. There were no trees at all. But this is more on the fringes here, and the scientists were amazed to think that just the way the regrowth took place in unforeseen kind of ways. For example, nobody ever dreamed that ground squirrels and gophers and things played a part in the rapid regrowth at a place like this, but they did. When they saw that blast cloud coming in over their heads, they said, we're not going to outrun this, boys. And so they burrowed down into the ground, and when that blast cloud went over them, right, and everything cooled off overhead, they began burrowing upward, mixing the seeds and the soil with that rich volcanic ash. And they were very effective farmers that facilitated a rapid regrowth of the plants and vegetation. And so a lot of unforeseen things happened. It's very, very interesting to me when you take a biological system and you shift it out of its equilibrium, how does it spring back again? Sometimes it happens in very unforeseen kinds of ways, right? And here is Dean of our graduate school, Dr. Ken Cumming. By the way, we have a graduate school at our institute. It's one of the few places in the world where you can earn a Master's of Science degree in geology, biology, physics, or science education that's based upon a biblical framework of Earth history. We don't study the Bible, but we study science from that perspective, all right? And it's a very stimulating kind of a place. But this is Dr. Ken Cumming, PhD, Harvard, who was doing some studies on regrowth at Mt Saint Helens, all right? Elk took up a new behavior nobody knew elk did before. They were found wallowing in these mud puddles, these volcanic ash-rich mud puddles, out in the open sunlight of the blast zone. Turns out they think the elk were coating their hide with that volcanic ash, which kind of served like sunscreen because they normally dwell in the deep forest, these creatures. And so elk took up a new behavior. What other kind of things? You know, the deer were having record numbers of twins and triplets after this eruption. Was something happening in their hormonal system that made it seem like everything was more rich after this eruption? It was like, wow, it's kind of staggering to think about, all right? And it makes me wonder, you know, how was it that, you know, with a big catastrophe, you know, Scripture talks about a global flood, Jesus talked about a flood. He said, as it was in the days of Noah, so shall it be when the Son of Man returns. He predicated his second coming on the historicity of a global flood, right? Jesus believed that. Moses believed it. He wrote about it in Genesis. Peter obviously believed in it in his epistle. Don't you think we should, even now in the 21st century, believe it, right? And so the idea of the flood, it makes me wonder, after a global catastrophe, how did plants and animals repopulate the earth? It's a real stimulating thing to think about when you take a system like that and shift it out of its equilibrium and make a brand new earth afterwards, right? Mt Saint Helens gives us a little picture of that. So this volcano, I think, will go down on record as challenging the way we think about how rapidly layering can form, how rapidly erosion of canyons and things can form, even things like petrified logs standing upright in an outcrop, and things like coal and rapid biological recovery. I think this volcano is going to be a real historical watershed event in the pursuit of Earth history in our country, because this is the most well-studied volcano ever, right? And we know that Mt. Saint Helens is absolutely puny compared to other volcanoes that have shook this earth, shook North America in the past. If you notice in this diagram here, Mt. Saint Helens is the little tiny red cube in the lower right there, 0.7 cubic kilometers. That's how much volcanic material was blasted out of Mt. Saint Helens. It was absolutely puny compared to other volcanoes that have shook this earth, including North America, such as the Huckleberry Ridge Tuff in the Yellowstone region. It was about 3,000 times bigger than Mt. Saint Helens. If you were anywhere in North America when that thing blew, it would have ruined your whole day, right? Yeah. And so we know this earth has been shaped by catastrophic forces in the past. We live in a time of grace today, a time in which there are not major volcanic eruptions. Oh yeah, we get our catastrophes, but they're not earth-shaking kind of events, all right? They were. I think the Huckleberry Ridge Tuff, early post-flood period, when there were not many people around, I think that's when that thing lifted its lid, all right? So we live in a time of grace today. And there's a little story I can tell you. The volcano reminds me of a passage of Scripture also in 2 Peter. It says that God is not willing that any man should perish, but all come to repentance. And every person in this eruption of Mt. Saint Helens, the May 18th eruption, every person in that area had a warning to flee. All 57 people were given that warning, all right? And those 57 did not heed the warning, and they died with they were either lost or unaccounted for on that day. And Harry Truman, this old, kind of a celebrated old man of the mountain, who lived in a lodge right on the north flank of the volcano, he was warned repeatedly, Harry, you got to leave. This thing's going to blow. Harry, don't you see that bulge? This thing is really going to get after you here pretty quick. And Harry did not heed the warning. And I like to think, and he was famous for a lot of salty kind of language, but I suspect he said something like, Sonny, I've been here for years and years, and I've seen the sun rise and I've seen the sun set. I've seen the seasons come and the seasons go, the tides go in and the tides go out. Everything continues as it was in the beginning of creation. And you know what? Tomorrow will be just like today, only better. But for him, it wasn't, all right? And you know what? God has given us the privilege, those of us who are Christians, to warn the neighbors round about us to flee from the wrath to come. Because there will be a judgment on this earth. Christ will come again. And he's not going to come as the meek and mild lamb. He's going to come as the lion of the tribe of Judah. And but yet he's made a way of escape for us at this time. He's made a ark of safety. Because he said, for God so loved the world that he gave his only begotten Son, that whosoever would believe in him would not perish but have everlasting life. All right? That's good news to you, friend, if you know you're lost. If you know that if you don't know what you're doing on this crazy planet, if you're like me, like I was about 20 years ago, and you know you're lost, come to Christ today. Make it your day today, because Christ's arms are open wide for you. God so loved the world that he gave his Son for you and for me. All right? And so Harry Truman becomes a tragic example of somebody who did not heed the warning. Right? He could have fled, but he didn't. And so Mt Saint Helens, I think, will go down as a volcano that challenged our way of thinking. And I like to think that a volcano like this, when I was there in 1984, those beautiful reddish-purple weeds called fireweeds covered the mountain. It was purple. Purple's the color of royalty. After destruction comes royalty. Beautiful picture to me. And so I hope this has been a stimulating kind of a talk for you. Now, in our second lecture this evening, we're going to look at radioisotope dating. And I'm going to try to keep it simple and just try to hit the punchlines and hope it'll be profitable for you. Thank you for your attention. Thanks for coming out on a Wednesday night, holiday week. Thank you. Thank you.